guys, we are on week 4 memory. We are working on filter, the less comfortable version right now. Now this is a tough code even for being less comfortable, so I'm going to do my best to explain it and see how we can help you guys out. Get this code in here and get it done. Now the hardest one by far is going to be the blur function, but there is critical reading here this week. So things that you're going to need are here in the reading. It does explain the blur function, it explains reflection. Very importantly, it explains the sepia version and it explains the grayscale version as well. You guys have to go over these. It explains how to accomplish the filter effects, and it does not give you a lot to go on. So without reading these, you won't really have the right understanding that you need to get this done. So make sure you guys go through that. You can see that we're working on the helpers C file here to go ahead and make those, and we're going to get started right now. We're going to take a look at this program, see what it provides you, and see how we can help add some notes to code it. So let's get started. Alright guys, hopping in here, we have our filters here. Okay, there are some things that are already declared that you should be reading over. There's an important one here, RGB triple. Okay, so you can see that you're allocating the memory for the image. Now that's important because under helpers C, you'll see that void, sepia, every one of these has the RGB triple in here. That already has memory allocated to it. Now in some of these we're going to have to allocate temporary memory to them before we release them and make the correct alterations to the original file. But it is important to look over these. You should be getting into them, getting an understanding of what they're doing and how they're helping out. Now I do want to point out there are some things here like Studio H and Studio Lib H that actually could be added to the helpers.c file. Technically though, you don't need them. I like to add them for congruity, because if you've got them on the filter C file, which is communicating with the helpers C file, then it would make sense to have the same libraries in there, but we don't need them. So what I'm going to do is I'm just going to add the libraries we need, which in this case should only be one, and we'll go over that once we get there. So let's get started with grayscale. To convert an image to grayscale, we need to get the averages of the RGB values. That should say values there. Let me update that. And then we need to set all of the averages to that value, because what we're doing with the grayscale, essentially we need a function that takes the height and the width of the 2D array, the image, right, of the RGB triple, which is here, right, height, width, and RGB triple, and we need somewhat of a nested for loop to iterate over all the pixels in the image, where the outer loop should be going over all the rows in the image and the inner loop should be going over all of the columns. So each of the pixel in this code is going to calculate the average red, green, and blue colors for those, and I'm going to store them in a variable called average, right? And I'm going to use a formula to calculate the average, which means we're going to need the math library. And because there's 3 colors, red, green, and blue, we're going to divide them by 3 and get them to the nearest integer, right? Finally, for each pixel in the code, we're going to set the red, green, and blue color channels to the calculated average, basically converting all of them to a grayscale. So let's get started with our first outer for loop, right? So let's open this up. For int I equal to 0, I is less than height, which is declared above, I plus plus. And now we need to open our nested for loop to go over the width, right? So for, we already used I, int j equal to 0, when j is less than the width, j plus plus. And let's go ahead and fix this little error right here, not equals to equals, that's plus plus. So in our nested for loop, we are going to get the average of the RGB value, which I put in the notes right here as our second to do. So let's go ahead and get that. So int average, we're going to declare that variable, right, is equal to int image. We need our variables here, I and j. And we need the RGBT of blue. Remember, we're adding all 3 of them and dividing, right? So we need the same thing for green and red. So image I j dot RGBT green plus one more image ij and dot RGBT red. And we're going to divide those by 3 and we want to round to the nearest integer. So I'm going to add plus 0.5, and I'm going to go back in here and add the missing parenthesis right there, and that'll close that out. So next we need to set all of these values to the average, right? So let's go ahead and do that. What we're going to do is go to a new line here. So image ij dot RGBT blue, that was our first one, now equals the average, and we need image ij RGBT green equals the average, and image ij RGBT red finally to equal the average. And let's get rid of this. And these for loops are all closed out right here. So next we need to move on to sepia. So with sepia, again, we need a similar nested for loop because we need to go over the width and the height, right? So you're going to kind of see a similar theme on these nested for loops because you need one to go over the width and one to go over the height. So we'll kind of be sticking to I for height and J for width, and we'll constantly have those for loops. Then for sepia, we need to store the original green, red, and blue variables actually into temporary variables. So this is where the memory functions come in, right? Finally, we need to calculate the sepia values for red, green, and blue. We're going to be using the formula that was provided to us in the reading here. Again, I told you that was going to be an important formula here. So if we go to our sepia function here, we are going to be using these formulas to help convert the RGB values to the output that they've asked for via these calculations. So let's get started and see what that looks like. So let's scroll down a bit, getting this moved up to the top. And as you can see, get the originals of RGB, set the values to sepia version of the originals from the notes. So again, even though there were some notes in here, I like to put the extra notes in to tell me what I'm going to be doing to help keep me reminded of what the code should be doing as I'm doing it. So let's get started. Again, doing our nested for loop here. So let's get rid of this for now. So for int I equal to 0 and I is less than height, I plus plus, and we're going to open our nested for loop to go over the width. So for int j, as we did before, equal to 0, j is less than width, j plus plus. And let's open that for loop up. So now we need to get the original values of the red, the green, and the blue. To do that, we're going to declare some things here. So int original red equals image ij dot RGBT red, and similarly original green equals to image ij dot RGBT green, and finally, you guessed it, original blue equal image, and let's fix image right there, ij RGBT blue. Now I'm going to throw in a note here. So now that we've stored those, we want to set the values of the images to the sepia values from notes. So now we're going to take the original calculations that are provided right here in the code, and we're going to put those in our code, changing original green, original blue, and original red by the calculations that it has right here. Now you can see original red, original green, and original blue were what they were called in this code, which is why we set them to that in our code. So let's go ahead and get that done. So image ij dot RGBT red now equals f minimum 255 int 0.393 times original red plus 0.769 times original green plus 0.189 times original blue plus 0.5. So that one is converting red, right? Now we need a similar function. Let me get this fixed right here. And they always recommend never doing copying and paste, which is probably a good rule to follow, but since we're just changing some various things here, I am going to break that rule and I'm going to go ahead and copy paste. So what we're doing on this one now is we're not doing the red, we're doing the green, and the last one, that's not green, it's green, is going to be our blue. So let's set those. Now the calculations in these aren't the same, they're not identical, so you have to go over those. So again, your red is here, your green is here, and your blue is here. Now I have these notes on a different screen that you see me taking peeks at here, and I'm just going to plug them in as I see them. So we have 255, we have 0.349, and then we have original red. And it is a good thing I did copy and paste, otherwise I might not have noticed that space there. So 349 original red, so this one is 686 for green and 168 for blue. And that's not convert red anymore, that's our convert green, and this one's going to be our convert blue. And for blue we have 272, 534, and 131. And that is going to do it for our sepia code there. We are going to move on to our reflect image horizontally. Alright, so to reflect an image here, where you need the same nested for loops to go over the width and the height, except we need a new condition where the left half of the image is swapped with the right half of the image. Because if we swap the right half with itself, then it just results in the original image. If you take an image and you only move the right side of it, it doesn't change the image. So we're going to be moving the left to the right. And this time within the nested for loops, we have to have a temporary variable. So we're going to be use temp. We're using this to store the pixels on the left half of the image temporarily while the value is overwritten with the value of the corresponding pixel on the right half of the image. So the value of the corresponding pixel on the right half of the image is going to be stored in temp, completing that swap. And at the end of the function, we're going to have the image horizontally reflected with the left half of the image now appearing on the right side and the right side appearing on the left side. So let's take a look at how that looks. And before we do that, I just noticed I'm missing a semicolon up here, so I'm going to go ahead and scroll up there and plug that in. And then just make sure I have them up there. That looks good. Okay, so let's get working on reflect. Let's get rid of this for now. So let's get started on our same for loop. So for int I equal to 0, I is less than height, I plus plus, and we're going to nest our other for loop in here. So for int j equal to 0, j is less than width, j plus plus. So now we need something, and we're going to plug in a note here. So we need to swap the values of the pixels on opposite sides of image at vertical center. So we're going to use our variable here, RGB triple, and we're going to assign a temporary location for it of image ij, and image ij is equal to image I width minus 1 minus j, and this is going to be what swaps pixels, and image I width minus 1 minus j is equal to the temp location. So here we have our loop, right, our I, which is iterating over the rows of the image, and j that's iterating over the columns. And for each pair of pixels on opposite sides of the image, the code is first storing the pixel on the left side of the image in a temporary variable, temp. And then it assigns the pixel on the right side of the image that should be swapped by the left side of the image. That's the image ij equals image I width minus 1 minus j. Finally, it assigns the value of temp, which is the original value from the left-hand side, to the pixel on the right-hand side of it. So that's our image I width minus 1 minus j equals temp. So we're just taking those two pixels and we're swapping places with them, and we're going to do that on every one of them, which essentially is going to reflect the image as they're requesting. Alright, so let's move on to blur. Blur is a big one. It is ugly and it is difficult. In fact, it was so long I had to add 2 lines of code here. So blur, we are iterating over each pixel where the variables to store RGB values and the counter in neighboring pixels iterating in a 3x3 grid, alright? We're calculating the coordinates of the neighboring pixels, and we're skipping it if it's out of bounds, OOB, right? And we're adding the RGB values of the neighboring pixels to the total RGB values. We're incrementing the counter for all neighboring pixels, and we're setting the RGB values of the current pixel in a temporary array to the averages RGB of the neighboring pixels, and we're copying those blurred pixels from the temporary array back to the original. So blur is without a doubt going to be our hardest function. Let's get started on it. Alright, and before we get on that, I do see here that this should be RGB, not RDB. So I'm going to update that. And let's get rid of this for now. So the first thing that we need to do on this one is we need to create a temporary array to store the blurred pixels in. Alright, so we're going to do RGB triple, oh, that's capital, in a temporary height, width, and then we're going to copy the original pixels to the temporary array. So for same loops here, int I equal to 0, I is less than height, I plus plus, and our nested for loop here for width, for int j equal to 0, j is less than width, j plus plus. And we're going to open that up, and now we're going to copy the pixels to the temporary array. So temp ij equals image ij. Give ourselves some room here. Now we need to iterate over each pixel in the image. So for int I equal to 0, I less than height, I plus plus, and again for int j equal to 0, j less than width, j plus plus. And let's remove this space right here. Now in this we need to initialize variables to store the total RGB values and the counter for the neighboring pixels. So we're going to open that up and see what that looks like. Give myself some room here. So int total red equal to 0, total green equal to 0, and total blue equal to 0. And we're going to use a float here So float counter equals 0.00. Now because we used float, we're going to go back up here and we're going to include math.h. Get back down here. And now we need to iterate over each neighboring pixel in a 3x3 grid centered around the current pixel. So you have a pixel, you need to go over the 3x3. Think of it of Minecraft or whatever you're doing. If you're standing on a block to go around the outer ones, you need to go by 3x3 in each direction. So let's do that. So for int x, because we're doing coordinates, right, equal to x minus 1, x less than 2, x plus plus, and we need to do the same thing for the y, right? So for int y equals -1, y less than 2, y plus plus. And now with that, we need to calculate the coordinates of the neighboring pixels. So int current x equals I plus x, and int current y equals j plus y. And let's go ahead and fix this, space that out, scroll down a bit. Now we need to make sure that the neighboring pixel is not out of bounds, and we have to skip it if it is. So if current x is less than 0, or current x is greater than height minus 1, or current y is less than 0, or current y is greater than the width minus 1. If all of that is accurate, we need to continue. Now we need to add the RGB values of the neighboring pixels to the total RGB values. So we're going back to our totals here. So total red image, and we're doing current x and current y dot RGBT red. Fix this little error right here. And we'll do total green plus equals image current x current y dot RGBT green, and we'll do blue next. Total blue plus equals image current x current y dot RGBT blue. And we need to increment the counter for the neighboring pixels. Let's move this one down a bit. And we'll close those two loops right there. Now, going back to our inner loop here, we need to set the RGB values of the current pixel in the temporary array to the average RGB values of the neighboring pixels. So now we need to go back into our temporary here. So temp ij dot RGBT red equal round, and we've already included our math function, so we're fine there. Total red divided by the counter, and temp ij RGBT green round total green divided by counter, and temp ij RGBT blue round total blue divided by counter. And finally, we need to copy the blurred pixels from the temporary array back to the original image. So we need another for loop here. Int I equal to 0, I less than height, I plus plus, and we need the same thing for our inner loop. Let's go ahead and get some space here. Int j equal to 0, j is less than width, j plus plus, and now we just need to copy them back. So image I j equals temp I j. And finally, we're going to add that return function back in here. And we should be good. So let's go ahead and make filter. And we've got a couple of spelling and formatting errors here, so let's get started on these. I'm going to start on line 23. And we're going to fix the spelling of height. And line 32, original green. And thanks to our copy paste, we know that I misspelled that 3 times. And let's see what else we have here. Line 42, height again. Line 58, RGB. Line 64. Put that J in there properly. Line 67. Misspelling. Line 88. Typo as well. So let's see if we can make it now. Forgot to capitalize the Y on line 88. That's where I'm already at. So let's get that fixed. Make filter. And got these here reversed. Should be plus equal. And let's get our semicolon in there. Try that again. There we go, and the filter makes. Now again, I'm not going to go through all of the testing, but you guys should. So let's just see if this makes real quick. Run our check. Alright guys, I ran the check and I saw that the reflect was not working properly. I actually know what I did here. This is correct, but we need to add some math in here. So we actually have when j is less than the width divided by 2, right? Because we need to determine the center of the photo from where we're flipping it, right? So without that determining the center, we're not going to reflect it properly. So I've got that fixed. Let's go ahead and make it again. Alright guys, we are good. Sorry about that math error there on reflect. I should have pointed that out. I think I said that we need to determine the center for where to flip the left to the right, which is why the divided 2 comes by, because we need the width divided by 2 will give us the center, and we need to take those left pixels and put them on the right and then copy what was on the right back to the left. So we got that fixed. That was line 44. All of this works. Listen, I know blur is hard. You've got several nested for loops, including some if loops. We've got counters, we've got temporary locations. I did my best to explain this in a decent way, but if you guys have questions, Discord, comments, that's what they're there for. I'll help you guys out in any way I can. This was a big one. This one was tough the first time I ran through it. Hopefully it makes a little bit of sense to you, but if not, reach out and I'm happy to help you guys out. This is CS50. That was Filter. I'm Devin, and as always, you guys are awesome. I look forward to seeing you guys next time.